The sun is much more than just a big light in the sky. It is the very heart of our solar system, a colossal sphere of burning gas that has shaped the story of Earth from the very beginning. Every sunrise marks the start of a new day, and every sunset reminds us of the sun's constant, life-giving presence. The sun is the reason we have life on Earth. Its energy reaches across the vastness of space, warming our planet and making it a haven for living things. Without its light and heat, Earth would be just another cold, barren world. Plants capture the sun's energy through photosynthesis, turning sunlight into food and oxygen. This process forms the foundation of every ecosystem, supporting animals, insects, and ultimately, us. Every meal we eat, every breath we take, is a gift from the sun. The sun's warmth keeps our planet at just the right temperature, allowing liquid water to flow in rivers, fill our lakes, and sustain life. It powers the water cycle, lifting moisture into the air and bringing rain to nourish the land. Without the sun, Earth would be a frozen, lifeless rock drifting in the darkness of space. No warmth, no water, no life, just endless night and silence. The sun's energy drives our weather, fuels the winds, and gives us days and seasons. It's the reason we experience the changing colors of autumn, the renewal of spring, and the rhythm of life itself. The sun connects us to the cosmos, reminding us that we are part of a much larger universe. But our sun won't last forever. Like all stars, it is on a journey through time, slowly changing as it ages. The sun was born from a swirling cloud of gas and dust billions of years ago. Now, it's living its middle years, shining steadily and nurturing life. But one day, far in the future, it will grow old, changing in ways that will transform our solar system. By studying the sun's life cycle, we gain a deeper appreciation for the special moment in cosmic history we inhabit. It inspires us to look up, to wonder, and to explore the mysteries of the universe beyond our world. So, let's journey through time together to discover how our sun works, what its future holds, and what these changes will mean for Earth and for us as a species. By learning about the sun's fate, we not only unlock the secrets of our own existence, but also better understand our place in the vast, ever-changing cosmos. The sun isn't burning like wood, it's a massive ball of super-hot gas, mostly hydrogen and helium. Unlike a campfire, there's no oxygen fueling flames here. Instead, the sun is a gigantic nuclear reactor, blazing at the center of our solar system. Its surface temperature reaches nearly 5,500 degrees Celsius, while the core is over 15 million degrees, hot enough to drive the most powerful reactions in the universe. Deep in its core, nuclear fusion fuses hydrogen atoms into helium, releasing immense energy. This process is called fusion, and it's what makes the sun shine so brightly. Every second, countless atoms are smashed together under incredible pressure, creating not just light and heat, but also the very elements that make up our world. This energy travels outward as photons, bouncing around for thousands of years before escaping the surface as light and heat. Imagine a single photon's journey. It's born in the core, ricochets through dense plasma, and finally bursts free to race across space at the speed of light, reaching Earth in just over 8 minutes. Only a tiny fraction of this energy reaches Earth, but it's enough to power all life here. Plants use sunlight to grow, animals depend on plants, and humans rely on both. The sun's energy drives our weather, ocean currents, and even the seasons. The sun has been shining steadily for 4.6 billion years and is only halfway through its fuel. It's been a constant presence, shaping Earth's history and evolution, and will continue to shine for billions more years. Every second, it converts 600 million tons of hydrogen into helium, releasing more energy than humanity has ever used. This unimaginable power is what lights up our days and keeps our planet from freezing in the darkness of space. This stable, powerful engine keeps our planet warm and life thriving. Without the sun's steady output, Earth would be a frozen, lifeless rock, drifting through the void. The sun's gravity holds the solar system together, while its energy shapes our climate and ecosystems. It orchestrates the dance of planets, comets, and asteroids, and its influence extends far beyond what we see in the sky. Our star's nuclear heart is the reason our corner of the universe is so full of life. From the tiniest microbe to the tallest tree, every living thing owes its existence to the sun's relentless energy. The sun's stability is what makes Earth's environment so uniquely suited for life. Its consistent warmth and light create the perfect conditions for water, air, and life to flourish. It's truly a magnificent and powerful star, a cosmic engine that has shaped our world and continues to inspire awe every single day. The sun isn't always calm. Sometimes it erupts with solar storms. These storms happen when the sun's magnetic field gets tangled and suddenly snaps, releasing bursts of energy. Solar flares and coronal mass ejections, CMEs, send clouds of charged particles hurtling through space. When these particles reach Earth, they create the aurora, dazzling lights in the sky. But solar storms can also disrupt satellites, GPS, and power grids, and pose risks to astronauts. That's why scientists constantly monitor the sun for signs of big storms. Luckily, Earth's magnetic field and atmosphere shield us from most of the sun's harmful effects. Solar storms are a reminder of our dynamic relationship with our star. They show us the sun's power and its direct influence on our world. Even in its storms, the sun shapes life on Earth. Right now, the sun is in its main sequence, a long, stable adulthood. For billions of years, it's been perfectly balanced, gravity pulling in, fusion pushing out. This stability has allowed life to flourish on Earth. The sun's energy output is steady, keeping our planet in the Goldilocks zone, not too hot, not too cold. Over time, though, the sun is slowly getting brighter, about 10% every billion years. In a billion years, this extra energy will heat Earth, causing oceans to evaporate and triggering a runaway greenhouse effect. Eventually, Earth will become too hot for life, long before the sun's dramatic old age. The very process that gives us life will one day make our planet uninhabitable. It's a humbling reminder of the delicate balance that makes Earth special. Our time in the sun's stable phase is limited. The clock is ticking for life on Earth. In about 5 billion years, the sun will run out of hydrogen fuel in its core. This is a natural part of a star's life cycle, but for our solar system, it marks the beginning of a dramatic transformation. The sun, which has shone steadily for billions of years, will enter a new and turbulent phase. Gravity will cause the core to collapse and heat up, igniting a shell of hydrogen around it. As the core contracts, temperatures soar to unimaginable levels, setting off new nuclear reactions in the surrounding layers. Astronomers have observed similar changes in other stars, giving us a glimpse into our own sun's future. This new fusion shell will push the sun's outer layers outward, causing it to swell into a red giant. The sun will grow hundreds of times larger than it is today, engulfing the inner solar system in its expanding atmosphere. Planets that once orbited at a safe distance will be threatened by the sun's growing reach. The sun's surface will cool and turn reddish, but its energy output will soar. Solar flares and massive prominences will erupt more frequently, sending waves of energy and particles far into space. The once familiar yellow star will become an ominous glowing giant. The habitable zone will move outward, and Earth will be scorched by the sun's growing heat. Temperatures on our planet will rise far beyond anything life has ever experienced, and the delicate balance that made Earth habitable will be lost forever. Oceans will boil away, the atmosphere will be stripped, and the surface will become a molten wasteland. Rivers and lakes will vanish, and the sky will turn harsh and unrecognizable. Volcanic activity may increase as the planet's crust is destabilized by the intense heat. Even the toughest life forms won't survive. Microbes that once thrived in extreme environments will be wiped out, and Earth will become a silent, lifeless world. This transformation marks the end of the sun's stable life and the beginning of its destructive phase. The sun will no longer be the gentle star that nurtured life, but a force of cosmic change, reshaping everything in its path. The sun that nurtured life will become a force of devastation. Its transformation will be both awe-inspiring and terrifying, a reminder of the power and impermanence of the cosmos. Our planet's fate is sealed long before the sun reaches its full red giant size. The story of Earth and its star is a fleeting chapter in the vast history of the universe, destined to end in fire and silence. As the sun becomes a full red giant, it will swell to over 200 times its current size. Mercury and Venus will be vaporized, and Earth will likely be engulfed by the sun's outer layers. If Earth somehow escapes, it will still be a molten, lifeless world blasted by intense radiation. The red giant phase lasts only a few 100 million years, but it's a time of ultimate destruction. The sun will burn helium in its core, creating heavier elements like carbon and oxygen. Our solar system will be transformed, planets destroyed, orbits altered, and chaos unleashed. The sun becomes a cosmic factory, forging elements for future stars and planets. But for Earth, it's the end. A dramatic finale to billions of years of life. The red giant phase is brief, but catastrophic. The sun's transformation will erase the world we know. Our solar system will never be the same. After the red giant phase, the sun's core can't fuse heavier elements and becomes unstable. The sun sheds its outer layers, creating a glowing planetary nebula. At the center, the hot, dense core remains. A white dwarf, about the size of Earth but half the sun's mass. This white dwarf will no longer produce energy. It will simply cool and fade over trillions of years. The nebula's gas enriches the galaxy with elements for new stars and planets. Surviving planets will orbit this faint, dying ember in darkness and cold. The sun's journey ends as a silent, frozen remnant. Our solar system becomes a ghostly shadow of its former self. Earth will become uninhabitable in about 1 billion years, long before the sun becomes a red giant. If humanity survives, we'll face a choice: stay and perish, or find a new home. Mars could be a temporary refuge as it warms, and moons like Europa or Titan might become habitable. But when the sun expands, the whole solar system will be at risk. To survive long-term, we'll need to travel to other stars, an enormous challenge. The nearest star, Alpha Centauri, is over 4 light-years away. We'll need new propulsion technologies and must find an exoplanet like Earth. Our telescopes are already discovering promising worlds. The dream of a second Earth is moving from science fiction to scientific possibility. Humanity's future may depend on our ability to reach the stars. The sun's story isn't just about endings, it's about transformation and new beginnings. Our time on Earth under a stable sun is a rare and precious gift. Learning about the sun's fate inspires us to explore, innovate, and dream bigger. The same science that reveals our star's future helps us find new worlds and build the technology to reach them. The sun's elements will one day seed new stars and planets, continuing the cosmic cycle. Even in death, our star will help create new life elsewhere. Our existence is thanks to stars that lived and died before the sun. When you look up at the sun, remember its incredible journey and our connection to it. The sun's future challenges us to think boldly about our own. As we reach for the stars, we carry the legacy of the star that made us possible.